The conjugate root theorem. The conjugate root theorem says, if p of x is a polynomial function with rational coefficients, then any irrational roots of p of x equal to 0 that have the form a plus the square root of b occur in conjugate pairs. So we would have a plus the square root of b and a minus the square root of b. Those are conjugate pairs. Also, if p of x is a polynomial function with real coefficients, then the complex roots of p of x equal to 0 occur in conjugate pairs as well. So if we have a plus bi, we would also have a minus bi. We would have complex conjugates. Okay, so let's look at an example. Let f of x equal 2x to the fourth plus 5x cubed plus 5x squared plus 20x minus 12. F of x has a 0 at 2i. Let's find the remaining zeros. Okay, so since it has a complex 0 at 2i, by the conjugate root theorem, negative 2i must also be a 0. So x minus 2i and x plus 2i are factors. Let's multiply them. X times x is x squared. X times 2i is 2ix. Negative 2i times x is negative 2ix. And negative 2i times 2i is negative 4i squared. The 2ix's cancel out. Negative 4i squared becomes positive 4 because I squared equals negative 1. So this equals x squared plus 4. Then let's divide our original polynomial, 2x to the fourth plus 5x cubed plus 5x squared plus 20x minus 12, by x squared plus 4. And I'm putting in the 0x as a placeholder. So let's do long division. We have to do long division because we don't have a linear factor. Okay, so x squared times 2x squared equals 2x to the fourth. So let's multiply. 2x squared times x squared is 2x to the fourth. 2x squared times 0x is 0x cubed. 2x squared times 4 is positive 8x squared. We'll subtract this. So 2x to the fourth minus 2x to the fourth cancels out. 5x cubed minus 0x cubed. Bring down the 5x cubed. 5x squared minus 8x squared is negative 3x squared. Bring down the 20x. So what times x squared equals 5x cubed? 5x. So let's multiply. 5x times x squared is 5x cubed. 5x times 0x is 0x squared. 5x times 4 is 20x. Let's subtract. And 5x cubed minus 5x cubed, that cancels out. Negative 3x squared minus 0. Bring down the negative 3x squared. The 20x's cancel out. Bring down the negative 12. Okay, what times x squared equals negative 3x squared? Negative 3. Let's multiply. Negative 3 times x squared is negative 3x squared. Negative 3 times 0x is 0x. Negative 3 times 4 is negative 12. Let's subtract. And we get 0. So 20x squared plus 5x minus 3 is our quotient. Let's factor this. So negative 6 goes at the top because we need to use the x box and we need to do 2 times negative 3. 5 goes at the bottom of the x. What are numbers that multiply to negative 6 but add to 5? Positive 6 and negative 1. So in that box, we'll put the first term 2x squared, the last term negative 3. I'll put negative 1x here and positive 6x in the first row. So with the first row, the greatest common factor is 2x. In the second row, it's negative 1. In the first column, the greatest common factor is x. In the second column, the greatest common factor is 3. So we've got our factors are 2x minus 1 and x plus 3. So if we set that product equal to 0, solve for x, we'll use a zero product property. 2x minus 1 equals 0, or x plus 3 equals 0. Add 1 to both sides, 2x equals 1. Divide by 2, x equals 1/2. Subtract 3, x equals negative 3. So we still have 2i and negative 2i. And now we also have 1/2 and negative 3. Those are all the zeros for this polynomial function. So the zeros are, as I said, 2i, negative 2i, 1/2, and negative 3. Okay, let's look at a second example. Let's find a third-degree polynomial function with rational coefficients so that the function has roots negative 4 and 2i. So because it has a root at 2i, it must also have a root at negative 2i by the conjugate root theorem. So we've got x minus negative 4 or x plus 4 as a factor, x minus 2i is a factor, x plus 2i is a factor. I'm going to multiply the complex factors first. So x times x is x squared. X times 2i is 2ix. Negative 2i times x is negative 2ix. Negative 2i times negative 2i is negative 4i squared. The 2ix's cancel out. We've got x squared and the negative 4i squared. Remember, I squared is negative 1, so that becomes positive 4. We've got x squared plus 4. So now we're multiplying x squared plus 4 times x plus 4. Let's distribute. X times x squared is x cubed. X times 4 is 4x. 4 times x squared is 4x squared. 4 times 4 is 16. I'm going to put this in standard form. So our polynomial function f of x is x cubed plus 4x squared plus 4x plus 16. And the degree of this polynomial is 3, so this is a third degree polynomial with rational coefficients that have the roots specified.